Man kan ju gå förbi, det gör det. Det kan gå förbi, det gör det.
Ja, nej. Man vet inte vad som är sant. Ja, jag behöver inte gå förbi. Jag bara
Yeah. Get into the town. So we have most of us are probably asleep, at least I was. We bunkered Swedish biogas right here in the port of Eastridge. Shipping is, as you know, one of the sectors that is hardest to decarbonize. We need energy-dense fuels. We need reliable logistics, port infrastructure, and commercial solutions that work not only on paper, but every day and night in real operation. Biofuels and biogas are one of those few marine fuels where we can take something that's left over from yesterday and actually put it to use already today in our vessels and fleets across the world. In Sweden, Europe, we produce it from manure, from food waste, from industrial organic residue, to mention a few of the available feedstocks, and basically transferring what we previously seen as a societal waste problem into a solution for the maritime transport. In 24, and I know that you guys know the numbers better than me, but I think we produced around 2.5 terawatt hours of biogas across 330 facilities in Sweden. In Europe, this number is of course vastly greater. But so is the energy demand of shipping, not only in the EU-related shipping business, but also of course globally. So the question right now is not if it works technically in our vessels, if we're able to produce it locally here in Sweden and Europe, but it's rather how do we scale it? That means liquefying it, certifying it, distributing it, and getting it all the way from the production facilities to the quayside and onto our vessels. So today I have with me a fantastic panel representing the whole range of this value chain. And we'll discuss what happens already today, some of the bottlenecks and barriers, and then finally, of course, concluding on what kind of collaboration do we need and what kind of new innovative business models do we see. My name is Mikael Osola. I'm head of Gotland Tech Development, and we'll work with the energy transition, the long-term energy transition of Gotlandsbolaget. So I think we start off here with each of you. We can start over at Johannes, giving a brief presentation of yourself, your company, and your role in this value chain.
Thanks. We're probably the least important player here. But anyway, Lunchseminarium, I work in DNV, in the maritime part of DNV, so we are a classification society. I work in the advisory section of and our role in the methane value chain and development has foremost been to develop the rules for safe design and operation and bunkering of use of first energy. And that is a job that is mostly complete. So I think we've done our part. And what we still do is that we, of course, we're engaging now more on the environmental benefits of blending in biomethane, looking at use of biomethane in green corridors, and some of the logistics of getting small quantities of biomethane to the bunker and in new places and so on. And, yeah, that's our work.
Hi, my name is Elin Malmgren. I'm at IVL, Swedish Governmental Research Institute, and I'm there as a researcher and an expert, as well as project manager. So our role in this context is kind of broad as well. I agree with Hans that we're also one of the more lesser players as of this, but my focus is primarily on environmental benefits, optimizing system, logistic curves. At what scale does this have great environmental benefits? What are the risks? How do we mitigate? So a lot of like expert support, reports, contextualization.
Yeah, good morning. Hello. Good morning. I'm Daniel Jens. I'm from Sawyer Group. And the reason this panel's in English, so you can blame me for that. I am more than 20 years in the shipping industry. I specialize in decarbonisation and alternative fuels. And when I talk about decarbonisation, I talk specifically about commercial decarbonisation. So that is, this is one thing to buy alternative fuels, but it's another thing to get paid for burning alternative fuels. And that's what I really focus on. Sawyer Group is kind of one of the great innovators in shipping, I would say. They've developed vessel concepts in the 60s, ro-ro vessels, very famous for it now. And the next kind of frontier for Sawyer Group is in alternative fuels. And my role here is to lead that marine energy transition.
So, my name is Johan Laurer, and I work for the Swedish Gas Association. We do not only work with the maritime sector, we work also with the industry sector and the road transport sector. And it's very important to try to connect all of these three sectors, of course. And currently, I work as a project manager now, and I'm the leader now of an innovation cluster where the maritime sector is a big part of that. It's called the Drive Cost, and it started a couple of months ago. So I'm very looking forward to be part of this panel. Thank you.
Hi everyone, my name is also Johan. That's my surname. Heading up our business development team in ST1 Biocraft. ST1 Biocraft is a Nordic growth company within the full biomethane value chain. Present throughout the whole value chain, so producers and distributors of this product, and had the pleasure to deliver this homegrown biomethane to make it the other day.
Thank you. So if we start off a little bit with the current situation, I gave some very broad numbers, and perhaps Edin or Johan could elaborate a little bit. What does the availability of bio LNG look today? If you talk about, let's start with Europe or Sweden.
If I go first, then you will. Yeah, as you mentioned, Mikael, we produce approximately 2.5 terawatt-hours in Sweden, and then of biogas. And then we import also approximately 2.5 terawatt-hours. So somewhere between 4 and 5 is what we use in Sweden. The potential, when if we talk about biogas specifically, and I've been involved with a lot of Elin's colleagues also that have done great research in this area and also look at the potential. The potential is often described as somewhere around 28 terawatt-hours in total. But if we look at the most maybe easily achieved, then we talk about maybe 15 terawatt-hours. But then, of course, we can talk about gasification, and we come up to this 28, 30 terawatt-hour. But then, if we look a little bit more into the future, of course, e-fuel and e-methane is the sky's the limit, more or less. But then, of course, then we have to have the electricity for that. But, so that's the number roughly. And today, I think there is somewhere around 80 new production facilities that is planned to be constructed for producing biogas, but most of them are on farm scale level. So it would be nice to have some of these bigger, like 120 by 150 gigawatt hours facilities.
You mentioned here potential, easy
Yeah.
potential, a little bit harder potential. I know that you've been working in a lot with this. Could you elaborate a little bit? What are the sort of, can you see, what do you see the technical developments required to make this happen on the scale?
I mean, it depends a little bit on what strain we're talking about. So what source, as Johan mentioned, when it comes to around 1514, it's not much technical potential. It's more investment and infrastructure and production. And then we're also talking about easily available strains. And also those that have some form of competition with other sectors and other use cases. Then when you come more to gasification, more advanced technologies, then there's some work left to do, primarily on the production side. There's not much difference in use case, there's not much difference in quality, but the effectivity needs to go up to make it cost effective. We see some strains on that. And I think also mention the small scale. There you have a lot of like very specific groups that you could very much focus on.
And what's the trick then? How do you get this small scale production onto the bigger scene?
Yes, so you can take that.
Thank you. Great question. As you know, in Sweden, we don't have a national gas grid. We have this on the western border because of the västsvenska gasnätet. It's approximately 350 kilometers in total, but that's what we got. And of course, we have like the city gas network in Stockholm, but that's only of city level. So what is needed is actually to get a cost-effective, small-scale production of liquefied biogas, because then we can transport it. So that's the key, I think. And today you have to have a production unit of maybe more than 50 to 60 gigawatt hours on an annual basis to have an economy and today in liquefaction. But there are small scale production that is being developed and introduced to the market now that I think will make a great difference. So that's for the future, because we have a lot of biomass in Sweden, but the biomass, we have to transport the energy then.
Yeah.
Transport biomass is very expensive, so we have to find ways to transport the energy more cost effective. And by liquefying biogas, we can get 2.5 times more energy per volume when we transport it. So that's good.
If we talk a little bit about, we'll come back to you, Johan, in a minute. Daniel, on as a ship owner, so what are you doing already as a shipping company, and how do you view bio LNG or biofuels in relation to other alternative fuels on the market?
Yeah, I think to answer that, you have to look back at what we have done. And I think there are, especially in Sweden and Scandinavia, there are numerous shipping companies who made quite a bold decision to invest in LNG technology 10, 15 years ago. I was part of a company that did that. And at the time, it was seen as, I wouldn't say a gamble, but it was seen as something, there was no small scale infrastructure. The bioenergy didn't really exist as a concept at that point. It was something to be reached in the future. And you know, it was a big decision to take. I would say that in the last couple of years, you know, internally, I would say that we enter our kind of post LNG era. Actually, the LNG was a transitional fuel we always said it would be for our own fleet. Actually, now we've phased that out. In my former employer, UECC, which is a group company of Sawyer, we switched all LNG to bioenergy. The vessels run all the time on bioenergy. And that was made possible for a couple of reasons. One, through these locally liquefied bioenergy, which has been mentioned here by Johan. I think that is a more challenging fuel to bring to the vessels because in terms of scale, in terms of cost, it's very difficult to make the economies work when you're building a small biomethane plant, which is locally liquefying, when you have competition from somebody who is bringing gas from anywhere in the continent across the European grid. That's what we do as a shipping company. So we basically tap into all the different streams of bioenergy. That could be Spanish biomethane, it could be Swedish bioenergy, it could be from Poland or anywhere else. And we look at how we can get it to the vessels. Now, logically, shipping companies will look to get it the most efficient way to the vessels and the most cost-effective way to the vessels. That often doesn't mean doing it locally liquefied at the place where it's produced. Instead, you make use of the interconnected grid. And that's something that's a bit of a risk in Sweden, that bioenergy production sites can be priced out by the fact that it's much cheaper and more cost effective to move gas across the grid. To speak a bit to what we do in the future and how we see bioenergy in general, it has a huge potential as a transitional fuel, but I mean, really as a real long-term fuel. I mean, I talk about the LNG transition we've been on being maybe 10 years. Bioenergy has a much longer future. And what we do now is we're looking to contract bioenergy feedstock and actual sourcing offtake agreements for the long term, for 10+ years, which is very unusual in the kind of the bunker industry. And the reason for that is there is a finite supply of these streams that we're talking about, and there is especially a finite supply of the really high quality, low carbon intensity streams that we specifically want in the shipping industry.
Thanks, Daniel. If we move a little bit to perhaps bottlenecks or barriers, and Johan, so what do you see in terms from your side as a producer? What are the major bottlenecks or barriers into increasing production, and primarily in Sweden, perhaps for your case?
So first of all, I'd like to agree to what Dan said. We also see the great potential in bioenergy, and that's the reason why I mentioned that we are a growth company. We are investing in roughly €1 billion in coming years to really scale this industry, targeting 3 terawatt-hours of own production and 6 terawatt-hours of sales to the market in 2030. That's 6 terawatt-hours, that's the 400,000 tons of bioenergy. So we also agree to the great potential, but there are bottlenecks, and you know the value chain is quite long, from the feedstock, the substrate, out to the vessel in this case, or the some other vehicle or industry or whatever. So yeah, the infrastructure and de-risking the whole value chain between the different parties is something that's obviously helpful.
So, of course, one thing that has been driving a lot of the bio uptake in shipping now for the last year at least is Fuelie Maritime, which you all know about. From your side, Hannes, sort of you're all over the regulatory space. What do you think are driving the development of uptake of bio besides Fuelie Maritime, and where do you see the perhaps largest risk related to the regulatory side?
Yeah, well, there was a very interesting discussion last year leading up to the IMO Net Zero framework on emission factors for LNG. And the process by which that is decided is different from Fuelie, where there's a standardized number, and there was the process in the IMO was going to be that they would pick countries would submit different value chains, LCA calculations, and then the job would be to pick the most conservative number, and that number would be likely much higher than the emission factor that is in Fuelie, so which changed around the scenarios that many owners with investments in energy capable vessels were looking to, and it would require blending in biogas much earlier. So I think I had to write this down, these numbers or these years rather, but you could see that in Fuelie you could get to 2030 with a 4-stroke engine, and to 2035 with a 2-stroke engine, but that would be 5 years earlier with IMO Net Zero. So that was a big possible event. But we'll see where it goes, where IMO Net Zero goes. But that's something that will be a game changer for a great uptake of biogas. Right?
Yeah,
just on that point on the IMO Net Zero framework, I think it's really interesting because obviously for those who are following it closely, there was a lot of hand-wringing and kind of upset at the fact that it was delayed, and now it looks on very shaky ground, largely thanks to the US administration and a lot of the Greek ship owners. But actually, the IMO Net Zero framework would be quite harmful to bioenergy as it is now, and to the energy pathway, as alluded to by Hannes. There's a lot of unknowns about the IMO Net Zero framework, notwithstanding whether it exists or not, what it would look like. But also everything in the IMO so far is about the tank to wake. It's about the emissions that happen on board the vessel. It doesn't look at the full well to wake process. And Future Maritime does. And obviously bioenergy specifically has all these advantages before the fuel gets to the vessel. So if you should have a regulatory mechanism which doesn't recognise the upstream avoidance of emissions, it's actually very damaging to the case of bioenergy. So, you know, it's one that the most interesting thing at the IMO to me is not whether and how the IMO net zero framework passes, but it's the life cycle analysis of fuels. How will fuels be considered within that framework? That's a really big regulatory risk. And it's actually a big barrier right now to a lot of shipping companies to investing heavily in these fuels for long term, because you don't know, are you going to get the recognition you need for that fuel in 10 years? It's reasonable to assume if there was a global regulation, the EU would dial back fuel maritime, be that in 5 years or 8 years or 10 years. But we're talking about long-term investments here. So that's quite a big barrier to shipping companies making these investments.
Is there you mentioned that a little bit earlier. Is there a risk also that shipping falls behind their other sectors? Now we talk a lot about biogas, but biofuels in general. It's not only the shipping community that uses these type of fuels.
Yeah, good question. Yeah, I totally agree with this. Also, that you have to look at this from also a lot of different perspectives, because as you mentioned, Mikael, today there are a bit of a competition between different sectors, and the ability to pay is also very different in different sectors. And I think this is very important also to highlight to both the public and I sometimes say politicians, they are actually humans also too. And so it's very important also to highlight the importance of having a maritime sector and a road transport sector and an industry that can produce fuel that we have total control of ourselves in Europe and Sweden also. Sweden, we have to look after ourselves, and that's not being protective or anything. It's just common sense, actually. I think that so we have to highlight this also to show that maybe the governmental support and the regulations of this has to take this more into consideration also, not only look at carbon dioxide emissions and things like that. Of course, that's important, but we also have to look at the resilience. Today, this week in Visby, resilience is a very hot topic, and for obvious reasons. So I think this is also need to be highlighted for the maritime sector. It's not only transport things for fun. It's actually doing a lot of very important service also by this import, export, and transport.
Yeah, absolutely. Johan, you wanted to comment?
Yeah, I can just agree to I think the mandated GHG market is the way to go. By doing that, you put the value on the fuels that actually decarbonize the most. And that's the reason why we are investing into bigger scale biomethane production plants based on manure, and exactly if you have to look at the full value, full life cycle, because then you can create that beautiful decarbonization numbers from biomethane. So I think as long as the stable demand is there, the volumes will follow.
So in terms of, if we move a little bit on to collaboration, that's a topic that we talked a lot about here in Almedalen. So what type of collaboration do we need to see to accelerate this uptake of biofuel? I mean, you've been working with Green Corridors, Hannes, anyone's free to comment here. What are the keys here?
Just on the Green Corridors, just really quickly, we had a lot of funding this year from Nordic Council of Ministers to support Green Corridors, and we were looking widely in the Nordics for who to support, and we quite quickly saw that biomethane Green Corridors, the cost basis, this was not, maybe these were too mature, they didn't need our help as much as so this manure-based biomethane really kickstart uptake of biomethane. It's nice to see.
Yeah, I can comment a bit on that collaboration. I think shipping companies traditionally have existed at the end of a chain. They take the product at the last mile when it's supplied by the bunker supplier. They don't get involved in, if you go back 20, 30 years, you wouldn't buy crude oil from Venezuela, you wouldn't own a refinery, you wouldn't have product tankers to move it around, and you wouldn't own the barges. But the way that Europe is positioned with an interconnected gas grid It's much easier to flow molecules. You know, you can move, you can inject, as I talked earlier on, you can inject gas into Spain, for example, and you can take it out in Belgium. You don't need to own the pipeline; it exists. You can always use it. So I think what we see as a shipping company is a greater degree of vertical integration. The shipping company at the end is the key unlock. The shipping company is the one who makes the emission reduction, the decarbonisation actually happen. You can have all the alternative fuel you want, but until it gets consumed in an engine, it doesn't exist. So it's completely logical to me that the shipping company takes a greater interest in that supply chain. What that looks like in practice for me, in my opinion, is that you don't end up with just a consumer at the end who just buys whatever's available in the market there. You take an active role in engaging with producers like ST1. You take an active role in engaging with those terminals where gas is turned from biomethane to bioenergy. And I think that's a key element to consider, that shipping is a very traditional industry. It's a very cards hold to close to your chest industry. There's never been a greater call for collaboration with other stakeholders in the chain than specifically in the case of energy and bioenergy.
Fully agree. Fully agree. So yeah,
Can I have a comment there? Just as agreeing basically with from the speakers, but also adding the fact that if you're looking from a well-to-make perspective with bioLNG or any type of renewable methane, how it's supplied and how the losses look like and what the DC changes is very, very, very important. So if you want to secure healthy economical benefits and decisions along the way, you need to collaborate. And then both directly with your own suppliers, but also like from us being slightly independent to collaborate with a lot of stakeholders and give out the information we can on this is how it looks like, and this is how we collaborate more. Or this specific field, no one is doing this, someone should. So I think that's the key to making it sustainable over time.
So if we take one, anyone can answer. What do you think is the most underestimated tool to accelerate uptake of biofuels or biogas in the shipping industry?
I don't know if it's underestimated, but like I said earlier, I'm repeating myself a bit. I think the GHG mandate, so in this case, purely maritime, is what's driving the demand.
And I agree with you one here also, that, but I also want to add, like I mentioned before, so I think that public awareness, we have to be much more proactive in to explain actually the importance of having a maritime sector that is vital and running, and that maybe have to come some extra cost for you to obtain that. And I think that's very important also to understand the importance of the maritime sector.
If you take it, because I'm technically interested, and I know you've been on it a little bit, Evan, if you take something that's related to biogas, and we see that you mentioned e-fuels a little bit and e-methane, if you talk about this value chain, LNG, bioenergy, and e-methane, how do you see that in relation to biogas production? Do you see any synergies or?
Well, yes. On a theoretical plane, there are many synergies. I think it comes down to CO2 as an additional resource and how that plays in. You have a potential for, I think, sorry for not remembering off the top of my head, but I think it's 23% increased yield at the site if you co-produce, if that's technically possible. No one is currently doing that. And that's from my PhD calculations. So it's doable. That's a synergy. So if you have a valuable chain, you can use it and combine. That's a potential. From a technical perspective, and we talk about resilience and redundancy here, it is a much quicker way of scaling up or reducing production. So if you want to secure a supply line in the future for renewable methane for a vessel, it could have a redundancy role as well as being potentially an environmental flow over time and sustainable flow over time. Yeah.
Yeah, of course, you like the technical side, Mikael. And I can just add, I just want to add also that I really like the Swedish gas grid because it's on the west coast. So it's not that I'm trying to neglect that, but there are biomass in the near region of that sector. I think the Research Institute of Sweden, and I don't know if the EL also made that calculation, has there's a potential of, I think, somewhere around 6 terawatt hours from the biomass in the total region. And of course, we have to really make that potential a reality. And a lot of the potential from that is today from straw. Straw is very hard actually to have in an anaerobic digester. In Denmark, for instance, they have a lot of research, not research, full production actually of this, that they take straw and make that into an anaerobic digester. They crush the straw and things. This is technical now. There's a lot of cellulosic structures in the straw that makes it hard to. But that's the fact. We have that biomass. We have to use it, and then we can top it off with a local production of hydrogen. We can inject that into the biogas reactor. We can turn the carbon dioxide in the biogas reactor, that is approximately 40%. We can turn a lot of that into biomethane by injecting hydrogen directly into the reactor. So that is also a way to really increase production. And so the tools are there and the softwares are in place. We just have to, not just have to, we have to really make that work also, because then we can inject that into the gas grid and use that.
Yeah.
Because then we have the infrastructure, for example, the port of Gothenburg site. So that's important. But then parallel with that, we also have to look at the potential that is in other places in Sweden that don't have the gas grid, as I mentioned, with small scale electrification and things like that.
Yeah. So if we find, I want to leave a few minutes for some questions also from the audience. For closing, if each of you could give like one concrete action that you would like to see during the next year. It could be policy, it could be industry actions or whatever. Just one concrete. If we start with you again, Hannes.
Sure. Yeah. E-methane there are e-methane goals in certain countries. So Japan has a goal on 1% injection in the gas grid in certain cities, and they built one e-methane factory. I think Europe has 10 or something. Finland has a national goal of 4% 2030, and I think that would go a long way. We don't have the same kind of gas grid as already mentioned, but that could be an option to kickstart e-methane as well, just to take that stance from government perspective.
Yeah. Yeah.
Second, always, but I also think like import rules on biogas and clarification on tax rules and all of those things, I would like to have very much cleared up.
We can talk about that afterwards, because I'm very interested in that.
I will just comment on isn't an e-fuel isn't an e-fuel forum. But just to comment on that, I think I don't share the same optimism for electrofuels. I don't believe that it's the best use of energy to produce an energy with losses. I also believe that energy can be used elsewhere. There is a place for it, and we see like co-located e-methane plants that together with biomethane plants can make a lot of sense. Because you have biogenic CO2, there's no point in taking it elsewhere. We've also got grid injection. You can put that e-methane into the grid together with the biomethane, and that can make sense. But I'm sceptical as to the future of e-fuels as a major fuel for the shipping industry. But if I would just comment on one concrete action for shipping companies, it's knowledge. I mean, it's like shipping companies don't understand that they own the keys to the kingdom. They have the assets that can do this. And specifically in sustainability departments of shipping companies, traditionally very backwards looking, I've been there, I've done this, I've filled out forms, I've filled out ESG reports for customers, told customers what the carbon intensities are. It's ultimately you don't get paid for that. That doesn't happen. Shipping companies' sustainability departments need to transition from being a cost center to being a growth driver, a generator. And sustainability departments traditionally are, normally when business grows, so your environmental impact grows. As you carry more cargo, you burn more fuel, your environmental impact goes up. The role of the sustainability department, in my experience and what I've tried to do, is to decouple that. The business should grow and the environmental impact should lessen. And that's what shipping companies focus on. And that starts by engaging with stakeholders in the supply chain, as I talked about earlier on. but it also starts with knowledge and understanding exactly these mechanisms and how you get the value out of the fuels that you burn.
Yeah, the start will come after you three guys there. But I think that I just take another aspect. I think, as I mentioned, I think that the maritime sector has to be much more proactive in communicating the very importance of this and the need for long-term strategy. It's easy to say, but the politicians and you, they have to understand it. So this is not like investing to buy a car or something that you pay off in 7 years or whatever. This is that's important. So we have to be much more proactive in communicating the importance of long-term perspectives.
Very good. So one beauty with bioenergy and biomethane is that it has contributed with so many different values to the society. It's decarbonization, it's resilience, and it's helping the farmers and so on. But one problem with that is that it affects a lot of different authorities. And so my short-term wish, if we focus on Sweden, would be alignment between authorities, so that we have one truth how the regulatory environment is.
Good. Thank you very much. Thank you, the entire panel, for excellent discussion. And I would like to open up the floor for questions now that we have gathered the intelligentsia in biogas and biofuels here. Any takers? Please.
Yeah, I'm Peter from Euromechanate. I have a question to you, Daniel. You're skeptical towards the e-methane or the e-fuels for maritime. Is that purely a cost issue or is it a volume issue?
I knew I shouldn't have said anything about it.
Sorry about that.
No, it's a physics-based concern, which is I don't understand that you use renewable energy to produce a fuel with energy losses, which the energy could be used for other purposes. We have looked at e-fuels in the past in different places. Of course, it's very different depending on where you are. And we looked in Finland specifically. Finland, which you would say is one of the most fertile grounds with lowest energy costs, a high degree of renewable energy. Still very difficult to make the numbers work on it. So that's the main reason for the concern. I'm not ruling it out for the future. In the same way that I talked earlier on that 10 years ago we had LNG, bio-LNG was a pipe dream. And now it's absolutely a reality for many shipping companies. I could be absolutely wrong, and e-methane might be a real reality for everybody in 10 years' time. I just don't see it in this moment.
So yeah, it's important to remember that why we need these small amounts of e-fuels 2030 is because they'll be important 2040. Biomethane is available now at much higher quantities than we are demanding, but we need to start to scale up these e-fuels as well. I think that's why the discussion is also now.
Okay, I just want to add one thing because I agree. We have to talk about person timing, the timeline here, and that is often forgotten. It sounds like it has to happen tomorrow, but maybe we talk about 20 years from today or 30 years. But I just want to add that the problem today with different sectors that do not communicate with one another really is that, just for an example, I read a couple of months ago that if we only look at the planned and the existing server halls in Sweden, like Amazon and Facebook, they are building huge servers. Today in Sweden, the electric effect that is produced in Sweden today is 25,000 megawatt. That's what is today. Only these servers need 8,000 megawatt. 8,000 megawatt. That's 1/3 of what we are producing today. We are talking about 4 new nuclear power plants. Just to put things in perspective, and that's only the servers. And then we need electricity for the electrification of transport sector, for all of the things. So of course, e-fuels have a very hard competition from this. So I would like also to have numbers, just to put things in perspective, because otherwise it's very easy to talk about it and we need to have electrification for everything. But when we don't put that in perspective, it's very hard to understand what we're actually talking about. the challenge to replace fossil fuel is unbelievable demanding.
That's a whole other seminar for sure. Yeah, please.
Thank you very much. Very interesting discussions here. My name is Marcus Olsen, coming from a company called Flowgas, and I have a question also for you, Daniel. Swedish biomethane production has been very much built up upon, I would say, off-grid plants. We have a few number of new plants also being potentially connected to the grid, but also when we come to expansion plans and so on, I see most of the plants being off-grid. Could you comment a little bit on how and if it would be potentially a segment for those off-grid plants to kind of join the maritime growth sector? How will that happen, and is it realistic?
It's a super question. And it's a bit unfair, actually, for biomethane producers around Europe who invested in local liquefaction at not an insignificant cost, by the way, to then see that mass balancing of biomethane across the grid is suddenly okay and allowed. Not only that, but you don't even have to liquefy the gas. You can just book virtual liquefaction by equivalence. It's super cheap. It's a huge competitive disadvantage, and I have negotiated and had a contract for 3 years in Galicia in Spain, an off-grid bioenergy plant, and this produced 30 gigawatts per year. And you know what? I did it, and I wondered if the customers that we had, which are car manufacturers, would pay a premium for like real, let's call it real biomolecules, not mass balance. They don't care, actually. They don't care at all. There was no premium for that at all, which is a shame, of course. But then we also have to understand that in order to facilitate the uptake of bioenergy across the industry, we need to use the interconnected grid. It's not realistic or practical that we can just rely on the small scale off-grid sites. Which then poses the problem. You need to look at where can they go to. So this plant in Galicia, for example, before we took it in the port of Vigo, which is about 100 kilometers from where the site production was, they were trucking it to Germany to inject into the road transport market. It's completely insane. So for those small-scale biogas local liquefiers, the maritime market could absolutely be an outlet for you. It's going to depend, of course, on logistics costs. I also would suspect it's going to depend on governmental support for the cost of liquefaction as well, because otherwise you're going to be completely priced out by mass balance. But look at the local markets and look at where there are, and engage with shipping companies who are engaged in that coastal trade where you are in the Baltic and Scandinavian region. There is plenty of LNG vessels going up and down the coasts. They could be good fits for off-grid bioenergy plants.
I think we wrap up with that question, and thank the panel so much. Thank you for coming here, listening, and I hope that you've learned something new about the biofuels and the application in the maritime transition. And wish you all a good rest of the day here in Almedalen. Thank you very much.